Just tell me if the screen is sharing with you.
Yes, ma'am.
All right, okay, fine. So see, under your class 12 syllabus, you have few units. So let me mention them to you. Let me just brief you with the syllabus of class 12th. All right. See, the very first unit that you have, which is a very long unit, that is electromagnetism. This is electromagnetism. So usually in your board examination, electromagnetism comes around of 34 marks. So the maximum weightage is given to this unit only. Then we have another unit, that is optics. In optics, optics comes for around 14 marks. Then we have unit that is known as the modern physics section. This is approximately around 8 to 12 marks. It varies, it keeps on varying. So maximum it comes for 12 marks. And then we have the very last chapter, that is the unit of electronics. Electronics comes for 8 marks. The least weightage is given, but this is a very scoring section. Now let me just brief you with the units. Under electromagnetism, one first part you have electrostatics. Yeah, boards are now split 35 each. Yes, Rishan, you're right. It's just that this is based on your old syllabus as well, but if you in totality calculated, the marks distribution is this much only. So now you can calculate it in the manner of your boards only. It's just that it's a round figure of the whole syllabus of 12th. All right, okay. So under electrostatics, you have majorly two chapters: electric field and charges, electric potential and capacitance. So we'll begin with this unit only today. Then you have current electricity with you. This is chapter 3 of your NCERT textbook. Then your chapter number 4 and chapter number 5 of NCERT, that is the magnetism part. So chapter 4 is magnetics and chapter 5 is magnetism. Then under electromagnetism only, you have electromagnetic induction, EMI, and alternating current, AC. And the last part of this unit, electromagnetism, this is EM waves, electromagnetic waves. So mainly your first book covers whole of this. So your first book is very important. It consists of these chapters. Now under optics, you have majorly two chapters. You have ray optics and you have wave optics. Ray optics and the wave optics. Under modern physics section, you have already covered a lot of portion in your standard 11th when you were studying structure of atom and chemistry. So if you remember dual nature of particle, dual nature of matter, that part is included in modern physics in your 12th, as well as one more thing that you have studied, structure of atom. So you have atoms once again in this section in your second term. One thing that is not included, that wasn't included in your chemistry when you were in 11th, that was nuclei. Under nuclei, the very new heading for you is radioactivity. All right, so this makes your modern physics section. So this section, modern physics, as well as this electronics section, this is a very scoring section. And electronics has a single chapter now, that is semiconductors. All right, so this is just a brief of your syllabus of class 12th. So we'll begin with electrostatics first. Under electrostatics, we'll start with electric field and charges. So just do one thing before we begin electrostatics, just note down the syllabus, and if you have any queries, you can always text me or you can unmute yourself. Just note it down once. Just text me in the chat box when you all are done. All right, so by now, I think most of you must have completed it. Shall we move forward?
Yes, teacher.
All right. Now see this section of yours, electrostatics. Basically, electro from electro you can at least derive out that this means electric charges. And statics, what is meant by statics? Statics means at rest. So the study of charges at rest makes up the electrostatics. So this is that branch of physics which deals with the study of electric charges which are at rest. So whenever we'll be talking about electrostatics, the charges will be at rest. Means you will not be considering the acceleration, you will not be considering the velocities of the particles, of the charges. All right. Now under electrostatics, as I've already told you, you have the first chapter of your NCRT as electric charge and field, and the second chapter as electric potential and capacitance. Electric potential and capacitance. Now see, whenever we begin with electric field, charge and field, so the first thing that we should know what is meant by electric charge. So charges you all are aware of already. You know what are charges. So just tell me according to you, just write me over here. What is according to you electric charge? What do you think is meant by electric charge? You are already aware of this term. Yes, anyone? Yes, Hamza, you are right. It's just that these are the very basic properties of matter. All right. You can even say these are the intrinsic properties of matter. Intrinsic property means these elementary particles, these come from within. So these are the intrinsic or the very basic elements. All right. This gives rise to various phenomena like electric forces, electric fields. So electric charge is basically the intrinsic property of matter. This is the intrinsic property of matter that gives rise to, or which gives rise to, electric forces. Now see, for electric forces, we have a separate section. We have a full law on how to calculate electric forces. We have Coulomb's law. So we'll be discussing this phenomena under that only. But just that the basic definition of electric charge is this only, that it is the very basic or intrinsic property of matter, which gives rise to different phenomena like electric field we'll be studying electric forces. All right. Now the SI unit. SI unit of electric charge. This is coulombs. So usually this is represented through a C. Like if I give you an example, whenever, what is the SI unit of force? Correct. Newton. Yes, right. Newton is the SI unit of force. So we don't write NEWTON all the time. How do we represent it? Through a capital letter N. So similarly, for representing electric charge, instead of writing coulomb all the time, we represent this through this symbol capital C. So this is SI unit of electric charge, coulomb, based on the scientist only, coulomb. Then we have CGS unit. So CGS unit is stat coulomb. This is stat coulomb, or sometimes this is also written as electrostatic coulomb. Electrostatic unit mainly. So electrostatic unit is represented through ESU only. So coulomb becomes the SI unit of electric charge, and CGS unit you can use electrostatic unit, ESU. All right. Now see, as rightly, CGS means centimeter, grams, seconds. All right, we have two types of units. One is the SI unit, which is the standard international unit, in which you have meter. Length, for length you have meter, for weight, like for mass you have kg, for time is seconds is fixed. CGS is a different system of unit in which this stands for centimeter, gram and seconds. So if you have, for mass you have kg as the SI unit, then the CGS unit for this is gram. If you have for time the SI unit as seconds, then in the CGS unit also the time remains as seconds only. Whereas for length, if you write, for length, if the SI unit is in meters, then in CGS unit this becomes centimeter. So the conversion which we do from the meters to centimeters, from kgs to grams, all these conversions are because of this unit only. So whenever you are provided any quantity, you have to write it in SI unit only. If you are given a question, until it has specifically mentioned you to write it in the CGS unit. Whenever the question is given, even in your standard 11th also, when you were doing your questions, if force was given, then you used to represent it through Newton only. Until specified, then you have to convert it into CGS unit. All right. So these are the two basic systems of unit. Now see, as someone's told, Hamza, I think. Yes, Hamza told positive and negative. So charges are of two types mainly, positive charges and the negative charges. If you classify charges, if I write types of electric charges, these are majorly of two types. First one is the positive charge, other one is the negative charge. So two types of charges are in nature. Now tell me, each one of you, write me or just unmute yourself, just tell me, is there is a basis for this classification? The scientist, whoever classified this as positive or negative, was there any basis of classification according to you, or you think that it was just randomly given, positive or negative? Just tell me. Any basis of classification according to you? I'm not asking you that classification. I'm just asking to you, yes or no. Do you think that there is a basis of classification for categorizing as positive or negative, or you think it's random? Okay, I have received answer for Hamza and Fatima. Rest of you, Rishan, Fatima, Munir, Hiba? Okay, so according to all of you, it has some basis. On some basis, it has been classified as positive and classified as negative. The actual answer is no. The scientist Franklin, when he discovered two kinds of charges in nature that were present in nature, he just randomly named them as positive and negative charges. There wasn't a single basis of naming it as positive or negative. It didn't exhibit anything that made it a positive charge, or it didn't exhibit any quality that made it a negative charge. These charges were given randomly. Had Franklin named it something else instead of positive, had he used the term north, now we use north and south pole for magnets, now that's a different thing. But at that moment, had he used for positive and as north and for negative as south, then in today's time, instead of having electron charge as negative, we would have been using them as north pole and south pole instead of having positive and negative charges. So these charges were named randomly. There wasn't any basis for classification of these types of charges. So positive charges and negative charges, these are just made randomly. All right, so do one thing, note till here, then we'll discuss some properties of these electric charges. And if you have any doubts, you can unmute yourself also and write me in the chat box as well. So syllabus you have written, write it, the electrostatic. Okay, so some of you who have joined in just now, Hafsa, Hamza Shekhani, and I think one more, Krishna. All right. So see, for those of you who have just joined in now, we were discussing, we have started with the unit electrostatics. Under this, we have two chapters, electric charge and field, and electric potential and capacitance. So we have started with electric charges and field. We were discussing what is meant by electric charge. So just note it down. I have written all the points on the screen. If you have any doubts, you can ask me. Electric charge is just the intrinsic property of matter that gives rise to various phenomena like electric forces, electric field. So this basic property that gives rise to such quantities and such phenomena, that quantity is known as the electric charge, whose SI unit is coulombs and whose CGS unit is electrostatic coulombs. So just note it down, and wherever you get stuck, ask me.
Ma'am, what is the first word after electric charge?
This term,
Um, Ma'am, the first word, first line.
electric charge is intrinsic property of matter which gives rise to electric forces.
Okay, ma'am.
This means the very basic property of matter. So we'll be studying electric forces, electric field. So these are only possible because of electric charge. You can omit this part. You don't need to write this. This I was just telling that in SI unit we have these quantities and in CGS unit we have these. If you all are done, just let me know, then we'll move forward. Just write me done in the chat box and I'll know. All right, so I think most of you have written. If anybody is writing, just let me know. Otherwise, let's move forward then. All right, so we were discussing types of electric charges. So electric charges are mainly of two types, the positive charges and negative charges. Now let us discuss what is this quantity of a single charge that we are totally referring to. See, when you are referring to the charge that is present in a single electron, let's say one electron is there. So this electron must be having number of electric charges. Charges make up this electron. So what is that electronic charge? That is this value 1.6 into 10 to the power minus 19 coulombs. So this is the minimum positive or negative charge that can exist in nature in free form. Means if a single electron, if I tell you this is the number of charges present in a single electron, so you cannot have any quantity below this. The minimum number possible, the minimum number of charges possible in a single electron is 1.6 into 10 to the power minus 19 coulombs. Now below this nothing is possible. Like you cannot have 0.8 into 10 to the power minus 19 coulomb of charges. Why? Because a single electron, this is done experimentally. This has been determined experimentally that what is the number of charges present in electron. So since a single electron is having this much amount of charge, it means this is the minimum quantity. Beyond this, it cannot have. Now see, if you double electron, like if you have two electrons, so the charges will get doubled. It will be 3.2 into 10 to the power minus 19. But below this number, below this charges are not possible within a single electron. So this is also referred to as the electronic charge, usually represented through the symbol plus or minus E. So whenever this symbol is represented or written E, remember that it is referring to 1.6 into 10 to the power minus 19 coulombs of charges. So you should remember this value as well, because many a times this value is not given in the question, and this will be used till your last chapter. Till semiconductor, this value will be used. All right. So this is the minimum positive or negative charge. See, when I'm writing positive or negative, this means for all the positive charges, this becomes plus 1.6 into 10 to the power minus 19 coulomb. For all the negative charges that we have, it becomes minus 1.6 into 10 to the power minus 19 coulomb. So the minimum positive or negative charge that can exist in nature in free form, this is plus minus 1.6 into 10 to the power minus 19 coulombs. So when I'm writing plus minus, this means for positive charges you should write the symbol plus, and for all the negative charges you can write the symbol negative. This much is, that is charge on, this is the charge on a proton and an electron. This is the minimum charge that is possible. So you should remember this value 1.6 into 10 to the power minus 19 of coulombs. Now just tell me, if any quantity is rich in positive charges, all right, so we say the body is positively charged, and if the body is rich in negatively charges, we say the body is negatively charged. Just tell me, if the number of positive charges and number of negative charges both are equal, then what do I say? Is the body positively charged now? Is the body negatively charged? If both the number of positive charges and negative charges are equal. Fatima is right. Hamza is right. Yes. Rest of you? Will the, yes, Krishna is also right. Hiba, correct. Yes, Fatima, Munir, Hafsa, all of you respond, please. Correct, correct, fine. See, if you have all the positive charges with you, and the body is rich in positive charge, then you say the body is positively charged. And if the body is rich in negative charges, then you say the body is negatively charged. But what if the amount of positive charges and the amount of negative charges are equal? Then simply you say the body is neutral, means no excess of charge. All the number of charges, all the positive charges that are present are equal to the negative charges. So this concept is also used, that you should know what is meant by a neutral body. So most of the objects in nature, these are neutral. What is meant by neutral is that they have equal amount of positive charges and the negative charges with them. So we are just doing the basics, so that when in the next classes we'll be using the terms like electronic charge, or we'll be using terms like neutral. So we all should know what is meant by this. All right. So just note down these 2 points as well. Then we'll do a bit more about an atom. We'll see the structure of an atom. Just note down these 2 points. So most of you have done by now. If anybody is writing, can stop me. All right. See, the major part of structure of atom that you have already studied in your chemistry. For your physics, if I tell you a structure of an atom, all right, tell me what is that central part? What is this known as? The central part?
Nucleus.
Nucleus, Fatma, right, nucleus. Now tell me, what does the nucleus consist of? All the elementary particles, protons, neutrons,
Prot-
electrons. Yes, Fatima, say.
Yeah, I was saying that.
Yeah. Out of all these elementary particles, the nucleus, this is the nucleus. This comprises of protons and neutrons majorly. All right. Now tell me, what are the structures that are revolving around these?
Electrons.
Correct, electrons. So electrons are revolving around this nucleus. This we'll be studying in detail when we'll reach atoms chapter, which is part of your second term. Now see. So see, what you have to remember, the types of bindings. All right. How an electron is bound to the nucleus, how a proton is bounded to the nucleus. All right. Now see, proton, proton. Proton is always held in the nucleus. Proton doesn't come out of the nucleus. Proton is held tightly in the nucleus. Due to which forces? Due to the nuclear forces. Due to the nuclear forces, these protons are inside. All right. Then electron, we have electrons with us. So the force with which the electron is attracted towards the nucleus, these forces, these are the electric forces. So electrostatic forces we'll study in this chapter only, and nuclear forces we'll see when we reach nuclei chapter. All right. Now just one thing that you have to remember is that this nuclear force means whatever is the internuclear force present within the nucleus, which is binding all these protons together. This nuclear force, this is 100 times stronger than the electric force. All the electric forces exhibited by electron. All right. So nuclear force is 100 times stronger than your electrostatic forces. These parts have been covered briefly in your 11th standards first chapter, introduction. All right. Now tell me. Okay, Heba, you tell me. If nuclear force is so much stronger than the electric force, so should the electron come out easily or the proton should come out easily? You can even write the answer if you are uncomfortable in opening your mic. Hiba. Till the time Hiba is answering, rest of you also tell me. Will the proton be more easily available to us or the electron?
Electron.
Yes, reason? Correct. Krishna is also right. Hamza is also right. Exactly. This is the reason. See, nuclear forces, if the nuclear force is strong, then it won't let the protons go out. If protons are held together using nuclear forces. So since nuclear forces are so strong, it won't allow proton to move out. Whereas in case of electric forces are not that strong as compared to the nuclear forces. So in comparison, I'm not saying that electric forces are weak forces. It's just that in comparison to the nuclear forces, these electrons will be available to us easily. So what you have to remember throughout the whole process of electrostatics, we'll be studying how electrons get transferred. Majorly, these are the electrons that transfer that creates currents and all the rest of the phenomena that we'll see. So that's why you should know what is the reason and which are available to us. You never see a proton getting transferred. You always see an electron getting transferred. The reason behind it is simply this: the nuclear forces, the strong nuclear forces and the weak electric force. Electric force weak as in comparison. So electrons are comparatively weakly bounded. Comparatively to these are weakly bounded than the protons. So to charge a body, always remember, whenever charging or whenever transfer of any charge particle occurs, it's the electrons that moves. The reason is simply because these are weakly bounded. You never see a proton moving, even if I say a positively charged body is there. So when I say a positively charged body is there, it doesn't mean that protons have accumulated in the body, that it is making the body as positive. It's just that it is deficit of electrons. That's why we say the body is positive. Whenever we are referring to bodies as negatively charged bodies, it means the body has excess of electrons with them. It's just the electrons that get transferred from a single body to another body. When we are saying electrons, a body is negatively charged, this means the body has excess of electrons. And if you say a body is positively charged, it means it is deficit of electrons. Whenever two bodies are charged together, we'll see charging of bodies and methods of charging also in today's class only. So whenever two bodies are charged, transfer of electrons occur to them. It is not the protons that transfer, it is the electrons that transfer from one body to another, making the body respectively by the amount as negatively charged or positively charged. It depends upon the number of electrons. Even if a body is positively charged and some amount of electrons have been added and making the net charge as 0, so if we say a body is neutral, then it means electrons have been added. If we say now the neutral body is negatively charged, means more number of electrons have been added. If we say that neutral body is now positively charged, means electrons have been removed. So is this concept clear? What is the immobile charge over here and which is one is the mobile charge that gets transferred? Any doubts still here?
No doubts, ma'am.
All right. So see, what I was referring to you mainly is this process that we call as charging. See, the transfer of electrons, this is mainly charging. When we say a body is charged, it means transfer of electrons has occurred. One more thing, redistributions of electron also occurs. Means we will see in that. Let's see in detail. Let me write the definition first. A body can be charged by transfer or redistribution of electrons. All right, and it's the electrons that gets transferred. Means negativity. If I say negatively charged body, this means it has gained electrons. And if I say a positively charged body, it means it has lost the electrons. It's the electrons that are getting transferred, electrons which are moving, which are weakly bounded. That's why they are able to make a body positive or make a body as negative. So see, if I give you an example, let's say this is a body A. It has 4 unit positive charge present in the nucleus, and it has 4 electrons revolving around. Okay, this is a body A. Now, Fatima Munir, you tell me, what is the net charge on this body? Yes, Fatima Munir. Net charge, how do you calculate the net charge? Anyone else?
I'm neutral, ma'am. Zero charge.
Neutral. Correct, Krishna. Yes, right. See, I'll correct you, Fatma. It's just that if it has 4-unit positive charge, means plus 4e is present in the nucleus, and it has 4 charges which are revolving, which are negative charges. So now you cannot write plus 4e and make it as 8e. All right, you will be taking as minus 4e. So that's why the net charge on this body A, this gets cancelled and QA becomes 0. So this is a neutral body. Now if I take another example, this I'm taking the same example, but this is a body B with these electrons and the positive charges present. Now I have added an electron over here. Now tell me what is QB. All of you, respond me. What is QB now? Similarly, calculated in this way only. For electrons, for negative charges, take it as minus, and for positive, take it as plus, and do simple mathematics. Yes, correct. It will be a single minus E. 4-unit positive charge from the nucleus and minus 5e for the electrons. So minus 5e 4e gives us what? It gives us minus of e. So it is rich in electrons, means this is a negatively charged body. Similarly, if I say let all the bodies be same, let's say this is the same body only. Let's say this is the same body, it has this much charge. Now I have removed an electron from this that was present over here. I have removed it. Now tell me, what is the charge on this? Now write me, what is the charge present? Correct. See, for the positive charges, we have plus 4e. For the negative charges, now we have as minus 3. You count it like this: 1e, 2e, 3e. So this becomes minus 3. So 4e minus 3e becomes positive E. Means a unit positive charge excess is present. So this is how transfer occurs. A body becomes positively charged in this manner and negatively charged in this manner only. Okay, so we'll see one more thing regarding the mass also, but before that you just note till here. And if you have any doubt, you can unmute yourself and ask me, or even if you can write to me. Write me in the chat box. I'll know. You have written these 2 points. No, you have to write it from here. All right, just note it down. If you have any queries, ask me. It is represented through 0 only. Okay, Fatima.
Yes, teacher. Thank you.
All right. So done, all of you. If anybody is writing, just stop me. Otherwise, I'm moving forward. Now see, this was the phenomena of charging. The transfer of electrons occur and the body that receives electrons becomes negatively charged and the body that loses electrons becomes positively charged. But how does this transfer occurs? There are various methods which with transfer of electrons can actually occur. So we have methods of charging. Methods of charging means methods of transferring electrons. This term charging represents over here the transfer of electrons only. So methods of charging. So majorly you have three types of methods for charging. First one is charging by friction. Secondly, you have charging by conduction. Then you have charging by induction. So these are the basic methods of charging. Charging by friction, conduction, induction. Now first one, friction, you have already studied. This is the same frictional force that you have studied in 11th standard. Conduction is different, induction is different. So first let us just discuss charging by friction. Charging by friction. So see, frictional force comes through interaction only. Forces comes through interaction in nature only. So if two bodies, these are rubbed together. what kind of force occurs which opposes them? The frictional force. So this frictional force is the same force which you have studied in your laws of motion lesson. All right, work, energy, and power, all the terms remain the same. It's just that whenever two bodies are rubbed past each other, a transfer of electrons occur. So if two bodies, these are rubbed together. So transfer of electrons occur from one body to the other body. And again, the body that loses electrons becomes positively charged and the body that gains electrons becomes negatively charged. So what happens? Work done while this friction, work done against this force of friction occurs. What happens? All the heat energy that helps in transferring of electrons. So I'll write it down only. When two bodies, for the friction, for charging by friction, the condition is that the two bodies should be rubbed past each other. So when two bodies are rubbed, whenever two bodies are rubbed, electrons get transferred. Electrons get transferred. So it's just a simple reason to it. The reason behind it, it is that work done against the friction while rubbing. Whatever work has been done when we are rubbing two objects together, whenever two bodies are getting rubbed past each other, then whatever is the work done to overcome this force of friction, this generates heat energy. As you all know, friction is what kind of force? It is a dissipative force only. So this generates heat energy. And this heat energy ultimately helps to transfer the electrons. It is this heat energy that helps to transfer the electrons. One more thing, whenever transfer of electrons occur, remember that electrons are not massless objects. Electrons have certain mass with them. 9.1 into 10 to the power minus 31. This is the electronic mass. The way electrons have their charge, electronic charge is 1.6 into 10 to the power minus 19. Similarly, you have electronic mass also. Electrons are not massless quantities. So tell me, if a body is getting addition of electrons, means the second example, if a body is having excess electrons, if I say Ma is the mass of this and Ma dash is the mass of this, so which one is greater? Ma is greater, Ma dash is greater, or both are equal? Just reply me in the chat box, or you can unmute yourself also. Zaid, are you from this batch only?
Yeah.
All right, that's fine. Yes, Zaid. Ma dash is greater. Ma is greater. All right. We have different answers. Yes. Yes, Zaid, were you saying something?
Yeah, I was saying MA dash.
Ma dash. All right. Ma dash. Okay. See, all of you are correct. It's Ma dash will be greater only. See, electrons have certain mass within them. So electrons, if a body is having addition of electrons, so associated with the electrons will be their masses as well. So as the transfer of electrons will occur, the electrons masses will also get increased. So a body that is negatively charged will have more number of electrons, and therefore it will be having more mass, greater mass. So that's why if you compare these two, Ma dash will be greater. One more example. This was the first case. This was the third example that we took. In this, we had removed a single electron. Now tell me if this is Ma double dash. Now compare it with Ma. Will it be same with Ma, greater than Ma, lesser than Ma?
Lesser.
Lesser than Ma. So Ma will be greater than Ma double dash. The reason is simple. Since electron has been removed, the associated mass has also been removed. So positively charged body has a lesser mass. So positively charged body loses electron, so its mass decreases, and a negatively charged body gains electrons, so its mass increases. So where you have written these 2 points, no, just add them. Mass increases and mass decreases. Before you forget, just add down them in your notes. All right. And let's continue, which we were discussing. Charging by friction. Okay. So see, so as I've told you, when two bodies are rubbed together, electrons transfer from each other. Now, if I give you an example, this is the case before rubbing. This is an object A, 4 unit positive charge, 4 unit negative charge outside. This is a body B. It has 5 unit positive charge and again 5 unit negative charge. So out of A and B, which is positively charged and which is negatively charged?
Both are neutral.
Both are neutral. Since plus 4e minus 4e, this will be 0. So QA will also be 0. And plus 5e minus 5e. So QB will also be 0. So both are neutral objects. Now if I give you a condition, the condition which I have given you is that in B, means in this, the electrons are strongly bounded as compared to A. I have given you this condition that the electrons which are bounded in B, see, overall electrons are weakly bounded as in comparison with made with protons. But if I'm just comparing object A and object B, so if I tell you in B, electrons are strongly bounded as compared to A. Now tell me from which it is easier to remove the electrons, from A or B?
From A.
From A.
We have different answers. Write me in the chat box, then I'll be able to understand whose answer is this. Fine. A, obviously, because B's the electrons present in B body, these are strongly bounded, so that won't allow electrons to move out, to get removed. Whereas in comparison to it, the electrons are slightly weakly bounded, so that will allow the electrons to move. So you should remember this concept that if a body is strongly bounded, then which should be positively charged, which should be negatively charged, because the body that will be having weakly boundations will allow the electron to move, so that will become positively charged. So this way we'll discuss a question as well, and questions come on this topic. From this topic, if a numerical kind of question comes or conceptual question comes, then it comes on the basis of this only, strongly bounded or weakly bounded. So as I was giving you this example, in B, I have told you electrons are strongly bounded as compared to A.
Teacher,
Now, yes?
it doesn't mean that the electrons in the body B cannot be transferred, right?
No. Yes. Electrons from body B can also be transferred. It's just that we have made a comparison between these two only. If these two bodies are kept together, if body A and body B, only these are kept together, and the condition is that B has strongly bounded electrons, then transfer of electrons will occur from A only. Let's say we have some other body C whose electrons are more strongly bounded than B, then transfer of electrons are possible from B to C. That is a different example. If you have just this case, so you always have to compare between two objects. In questions also that we'll discuss, you will be seeing where there are A, B, C, D different objects. So you take two objects, just identify which has weakly boundations, which has strongly boundations, in which electrons will move, then you can compare. It's not that electrons won't be able to move from B. It will move if a body you have which has strongly boundations than B. All right.
Yes, teacher.
Okay. So see, after rubbing case, this was before rubbing. If I give you this, if I say after rubbing, what has happened? So usually what happens if this was the body A and this is the body B. Yeah, both of these bodies were neutral. So what happens? An electron from A gets transferred into B. So here we are left with, okay, tell me what is the charge on A? Tell me the charge on A and B. Now, after rubbing.
Charge on A is positive.
Plus E, minus E, plus 4E, plus 2E. Any answer? Fatima, just be specific.
Plus 3E.
Plus 3E. Z, you were answering something?
Yes, ma'am. Plus 3E on A, and on B it will be negative charge, negative 6 charge.
Negative 6 charge. See, let's say QA for calculation of charges on A. Positive charges are 4. So it will be plus 4E, right? And negative charges are how much? Negative charges are 3. So minus 3. What is this? 4E minus E becomes plus E. So this is a single electronic charge. All right. When we are considering this now, plus 5E for the charges present in the nucleus. Now, how many electrons are there? 1, 2, 3, 4, 5, 6 electrons. Means minus 6E. This becomes minus E. So it is plus E and minus E now. All right, see your mistakes. I think you all have done calculation mistakes while calculating this charge only. Plus E and minus E only. A single electron got transferred from this. From body A to body B, a single electron got transferred. So the body became deficit in a single electron, which you can calculate and cross-check through the calculation of charges. And since the body received this additional electron, this made it rich in a unit negative excess charge. Is this part clear? How have we done the charges, calculation of charges, all of you? Or should I repeat? Anyone?
No,
Clear?
it's clear. Yeah.
It's
All
clear
right,
now.
Okay, okay. Now see, so this is just an example how transfer through friction occurs. When these bodies were in neutral state, they were before rubbing. After rubbing, it is possible that a single, I have taken a random example that only a single electron got transferred. It may happen 2 electrons get transferred, 3 electrons get transferred, and number of electrons get transferred while rubbing. It's just that you have to remember, if this is the case, then it is easier to remove electron from A than B. This concept will be utilized over there. One more thing that you should remember, just for your questions only and for your basic theory knowledge, we have few conventions. What happens if you rub a glass rod? Rubbing by friction only. This comes under rubbing by friction only. If you rub a glass rod with a silk cloth, if you have a glass rod and you are rubbing it with a silk cloth, then by convention we say there is no logic in it. You don't have to just take out logics for different materials. You just have to learn this, that by convention it has been proven that electrons get transferred from glass rod to silk. So if electrons get transferred from glass rod to silk, which will be positive, glass rod or silk?
Glass rod.
Glass rod.
Glass rod will be positive and silk will be negative. One more example, 2 examples you should remember that are sufficient. If you rub glass rod with silk, and one is when you rub wool and plastic. So again, electrons transfer from wool to plastic, making the wool as positive and plastic as negative. So in NCRT also, this glass rod and silk example has also been mentioned. So you should remember this value. If many a times it asks us that if a silk rod is being rubbed with glass rod, so what will be the charges accumulated? Questions will be random. It's just that if you know silk is negatively charged, then you will be able to figure it out. All right. So we'll see questions on this also, charging, how the questions come from this charging through friction. But before that, just note it down. And if you have any queries, ask me. And Zaid, for you, we have started with electric field and charges from electrostatics. And we have discussed before this, before you have joined, we have discussed what is the phenomena of, what is meant by electric charge, this basic unit of electric charge. So we have just discussed it in brief only. Electric charge is the intrinsic property of matter that gives rise to various phenomena like electric forces, electric fields. And for electric forces, we'll see different laws are there. Then we'll be studying electric field in detail. What you should remember is the transfer of electrons occur. Protons never get transferred because the protons, these are bounded through nuclear force, and electrons are bounded through electric forces. So electric forces are weaker in comparison to the nuclear forces. So what happens? Protons, nuclear force doesn't allow proton to move out, but electric force allows electron to escape. So if you say a body is positively charged, it means the body is deficit of electrons. It has not added protons in itself to make it positively charged. And if it is negatively charged, it means there is excess of electrons. So this is what we have done in brief. If you don't understand anything, just ask me. All right, Zed.
Yes, ma'am.
Now,
Ma'am, in this chapter, we will study about like static charge here.
yes, this unit deals with static charges only, electrostatics. We won't take the terms like velocity, acceleration, and all those terms which you have studied in motion in 1D and 2Ds. So charges are rest in there. Charges will move when we'll study chapter 3, current electricity. Moving charges
Okay.
will be producing current. Just let me know when you all are done.
Teacher, I am done.
I'm finished.
Okay, if
Done.
you are done, then let's just stop it till here. We'll begin. Just revise this part. We'll discuss it from here only. All right.
Ma'am, I have a question. Like when ebonite rod is rubbed or yeah, rubbed with a wool. So from ebonite rod, it will transfer a charge, or from wool, it will transfer a charge.
When
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 ebonite rod
ebonite
is
see, this is this receives electron, so it becomes negative.
Mhm.
And if it is charged with fur or any cloth, then that becomes positive. Means electrons are received into the ebonite rod.
Okay.
All right.
Yeah.
Okay, so all of those who have written it down can leave the class. We'll meet on Thursday whenever we have the next class.
Thank you, teacher.
Okay,
Thank
okay.
you,
Allah
ma'am.
Hafiz.
Thank you, ma'am.
Allah Hafiz.